everyone. In today's video, we are covering Section 2 of Unit 4. Section 2 covers the ASA and AAS Congruency and something called the CPCTC, which we'll talk about what that means in a little bit. So for our shortcuts, we have our third shortcut, ASA, angle, side, angle. We're going to go ahead and write that out. Angle, side, angle, saying if we can prove that two angles and their included side are congruent, then the triangles are congruent. So I have angle A and angle C, and then there's a side connecting the two angles, side AC. That's what I mean when I say included angle. So you have two angles and their included side shared between the two angles. So I have angle D and angle F, and this included side, DF. And those are the angles and side that we're trying to highlight. So angle, side, angle. That way we can show we have two congruent triangles. The other shortcut we have is the angle, angle, side shortcut. The angle, angle, side shortcut says that we need to show that two angles and the non-included side of one triangle are congruent to two angles and their non-included side as well. So I have an angle, skipping the connected side, to an angle, and then one of the other two sides. If I can show those three things, then I can show that my triangles are congruent. So I have angle, side, angle, where my side is between the two angles, and I have angle, angle, side, where my side is not in between the two angles. Alright, so we're going to practice knowing when to use which shortcut. So in example 1, we have which shortcut are we using? Angle, side, angle, 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 side, or neither. Now would be a good time to pause the video and try it yourself. And we're going to go through it here. So I have angle, angle, side. So that is the shortcut we need to use. Angle, angle, side. Here I have highlighted an angle and a side, an angle and a side. Is there enough information just from looking at this picture to know that these are congruent triangles? The answer is kind of. We're going to say we do because we know that we have two intersecting lines and those lines are creating vertical angles. So then what we really have here is angle, angle, side. Angle, angle, side. Now if I didn't know that two intersecting lines create vertical angles, then I would not be able to conclude that these are congruent triangles. And next we have angle, side, angle. Angle, side, angle. That's one of my shortcuts, so that's the one we need to use. Angle, side, angle. If you're still not sure, read it aloud as you're pointing at it. This is an angle, this is a side, this is an angle. Angle, side, angle. Alright, we're going to take a look at a couple examples of proofs using both angle, side, angle, and angle, angle, side. So we're going to start with this proof here. Example 2 says, given that JL bisects angle KLM and angle K is congruent to angle M, prove that triangle JKL is congruent to triangle JML. Alright, so we're going to start by writing our given statement into our first box. So I have two pieces that I'm going to put in this box. I have that JL, and I'm just going to write the word, bisects angle KLM, and I have angle K is congruent to angle M, and both of those things are given. Alright, so now that I know that we have this bisecting line and we have one set of angles, I need to show either that we have angle, angle, side, or angle, side, angle. As I'm looking at this, I'm only having information about one side, so we are probably going to need to be using this side because it's shared, and it says that we're bisecting this angle, so we probably need to be using these angles, so I'm really looking at angle, angle, side, but we will fill that step in just a moment. So we're going to go ahead and start with the piece of information that I just mentioned about how the bisecting line cuts our angle into two congruent pieces. So I have angle KLJ is congruent to angle MLJ by the definition of a bisector. And I can use the definition of a bisector and say that these are congruent because I already mentioned in my proof that JL bisects that angle. Alright, next I have this side that I mentioned here, and I should also mark my congruent angles on my image, so I'm going to do that real quick. Alright, now we'll go ahead and mention our congruent side. So I have this side here that is shared between my two triangles. Because it is shared, that means that I can say that LJ is congruent to side LJ. And if you remember what that property is, that is the reflexive property, which says that something is congruent to itself. Alright, so I showed an angle, and a side, so that means that I was able to prove that I have two congruent triangles using the angle, angle, side, congruence postulate. And I showed that triangle JKL is congruent to triangle JML. Alright, so this is a pretty standard angle, angle, side proof. Now we're going to take a look at another type of angle, angle, side proof, which has a little bit of a special circumstance in it. And that circumstance requires that we learn about the congruent supplements theorem. The congruent supplements theorem says that if two angles are supplementary to the same angle, then they are congruent to each other. So if I am looking at this image here, if I have that PQU is supplementary with RQU, then I also know using this theorem that RSU is also supplementary to PQU and TSU and so on. So we will go ahead and take a look at exactly more of what that means when we start working on this proof, because we do need to use this in order to prove that these two triangles are congruent. Alright, so in example 3, we need to prove that these two triangles are congruent. I'm going to go ahead and start by putting my given statements in. I previously have been writing my congruent statement in the bottom first because that's what we're trying to prove, but I'm not entirely sure how many lines I'm going to need on this one, and to be honest, I think I accidentally left a line off the box, but we'll find out. So we're going to go ahead and start with our given statements, which is really where you should start in the first place. So in my picture, I have these arc markings on angle PQU and on angle TSU that show that those are congruent. So that's my first given statement. So I have angle PQU is congruent to angle TSU, and I also have that angle RUS is congruent to angle RUQ, and I know that because I have this right angle marking here. So technically, the first one is given, and the second one is by the definition of a right angle. So it probably would be good to write that in two separate lines and say this is the definition of that right angle, but we don't really need to because it's marking it in there for us. So we're going to go ahead and just say that that is given. That's a shortcut that I'm allowing you to take. There's a couple shortcuts that I'm going to allow you to take in here, and for the most part I'll point out what those are, but we won't go in depth on a couple of them. Okay, so now that I've pointed out my given statements, there's a couple things that we need to write in so that we can use this theorem and show that we have two congruent angles. So the first thing that we need to say is that angle PQU and angle UQR are supplementary, and angle TSU and angle USR are supplementary. So I have in here angle PQU plus angle UQR is equal to 180 degrees, and angle USR plus angle TSU is equal to 180 degrees. Both of those by the definition of a linear pair. Okay, next, I said that angle PQU and angle TSU are congruent from my given statement. So because these are congruent, I can take one of these and I can substitute it in. So I will then have that angle PQU plus angle USR is equal to 180 degrees. So I have my next line, angle USR plus angle PQU is equal to 180 degrees using the substitution property. Okay, next, we're going to have to squish this one in because I want to put this all in one box. We have on here angle PQU and UQR are supplementary, and angle PQU and USR are supplementary. So I have in one line here angle PQU and angle UQR, comma, and angle USR and angle PQU are supplementary angles. Why? Because they add up to 180 degrees. So that's by the definition of supplementary angles. All right. Next, because I said that angle PQU and UQR are supplementary, and angle PQU and USR are supplementary, by the congruent supplements theorem, I can say that angle UQR is congruent to angle USR. So I have this right here. So I have angle UQR is congruent to angle USR by the congruent supplements theorem. All right. So I have now angle, 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 angle. Now I need to show that this side is congruent. For this, I have UR is congruent to UR by the reflexive property. And I'm actually going to take a second and extend my chart here. If you run out of room, oh, that wasn't good. If you run out of room in your charts, just go ahead and extend them. All right. And now that I have shown that I have an angle, and a side, I can say that triangle QUR is congruent to triangle SUR by the angle, side congruence postulate. Eventually we're going to be taking a shortcut and we're just going to write AAS, and that's all you'll have to put in there. So this is the whole proof. Each of these things that I put in one line, all of those things could be their own line. And there's also a couple other shortcuts that we could possibly take, and we will talk about what those are in class. The only thing I'll say now that I might allow you to do is to take this line out, but you technically do need it. And we can go into some of those details in another time. Okay, so now that we've proven this one, if you flip the page, you're going to notice that there's this proof right here, example 4. We're going to go ahead and skip that today. If you would like to see the video of this proof, I will record that and put that in the extras playlist on my YouTube channel, so you can check that out on your own time. And that might not show up right away, but it'll be there within the next few days from the time that you've watched this video. All right. So what we are going to do now is we're going to skip ahead to the CPCTC. CPCTC stands for corresponding parts of congruent triangles are congruent. And I'm going to go ahead and highlight that. Corresponding parts of congruent triangles are congruent. It can be used as a justification in your proof once you have proven two triangles are congruent. In other words, the CPCTC can only come after the side, side, angle, angle, or angle, side step. So you have to show that the triangles are congruent, then you can say their pieces are congruent. So in short, it allows us to say, since we've proven these three things congruent, everything else is also congruent. So let's go ahead and flip the page here, and we have a couple examples. Example 1 says, given YW bisects XZ and XY is congruent to YZ, prove that angle XYW is congruent to angle ZYW. Okay, so right off the bat, I'm going to recognize that I have two given statements, and they could go on the same line, but I'm going to write them in two separate lines this time. So I have YW bisects XZ because it's given, and I have XY is congruent to YZ also because it's given. So I have XY is congruent to YZ. I'm drawing that in on my picture so I recognize I know those things already. All right. So now that I have shown one side and I know that YW shares on both triangles, I can have a second side. So I'm going to go ahead and mark that this is in both triangles. So I'm going to say YW is congruent to YW by the reflexive property. And then I have, from these being bisected, I know that I have two more sides that I can say are congruent. So I have XW is congruent to ZW. Let's go ahead and write that out. XW is congruent to ZW. And I know that by the definition of a bisector, and I know they're bisected because that's one of my given statements. So I have definition of a bisector. Since I have now shown side, side, side congruent between the two triangles, I can say that I have triangle YWX congruent to triangle YWZ by the side, side, side congruence postulate. Since my triangles are congruent, I can then say that angle XYW must be congruent to angle ZYW, which is what I wanted to prove. And I can say that by that shortcut that I was just talking about, the CPCTC. Corresponding parts of congruent triangles are congruent. So I'm going to go ahead and write that out, and we're going to right ahead just jump to CPCTC. You do need to know what this means, but you can go ahead and just write it in as CPCTC. Corresponding parts of congruent triangles are congruent. All right, that's one example using the CPCTC. We're going to go ahead and use another example here. And I am going to point out before we move on that I don't know if you noticed, but I didn't jump right away to saying that these two triangles were congruent, and I didn't assume that it was going to be side, side, side. I had to figure out what I needed to use. You can pre-look at it and think about what you know and how that helps you, but sometimes you just have to start going and writing down what you know and continuing from there and seeing what's left and trying to figure out, okay, how can I find that out in order to figure out the whole proof. So this is kind of like a giant puzzle where you may have accidentally dropped a few pieces and you lost them, and you have to figure out exactly how to solve your puzzle when you're missing those pieces, and then later when you find the piece and you know what it is, you can plug it in. Alright, example 2. Given that NO is parallel to MP, okay, that's telling me that it is parallel, so I'm going to go ahead and draw my parallel arrows on there. And it says that angle N is congruent to angle P, so I know these two angles are congruent. Okay, so I'm going to go ahead and I'm going to take those and put them in my given statements here. So I'm going to write them in two lines again. So I have NO is parallel to MP because it's given, and I have angle N is congruent to angle P because it is given. And I'm trying to show that MN and OP are congruent. In order to do that, I need to show that these two triangles are congruent. So if I'm trying to show these triangles are congruent, the things that I see right away, other than that angle that's already marked, I know that this side is in both triangles. So I'm going to go ahead and point that one out. So I have OM is congruent to OM, and I know that by the reflexive property, which says that something is congruent to itself. The reflexive property. Alright, so I have an angle and I have a side. If I can show that another set of angles, it'd have to be this angle to this angle or this angle to that angle. If I can show that those are congruent, then I can say that my triangles are congruent. And in this case, I can say that because it says right here that NO is parallel to MP. And because NO is parallel to MP, and we have this line cutting through them called a transversal, I can say that angle OMP and angle NOM are alternate interior angles, so therefore they're congruent. So I'm going to go ahead and write those down. I have angle OMP is congruent to angle NOM by the alternate interior angles theorem. And this is that shortcut that I said that I use. You can use this in my class. You can't use this in the real world, so if I were you and you were planning on going a little further in math later on in your life, I would probably write out the whole thing. Alternate interior angles theorem. Alright, so now I have this angle is congruent to this angle is congruent to that angle, in order, angle, angle, side. So I was able to show that these two triangles are congruent using the angle, angle, side congruence postulate. So I have triangle NOM is congruent to triangle PMO by the angle, angle, side congruence postulate. Okay, so now that I have two congruent triangles, I can then conclude that all other pieces of those triangles, as long as they're corresponding, are congruent. So I have MN that I'm trying to show, and I can now say that MN is congruent to OP using the CPCTC. Corresponding parts of congruent triangles are congruent. Alright, this is where we're going to go ahead and stop for today. So we covered the angle, angle, side, the angle, side, angle, and the CPCTC shortcuts in this lesson. There's a lot going on and a lot of proofs here. We do have a lot of practice questions to help us with those, but if you're finding that you're getting confused or you're not sure how to identify which shortcut to use, or any of those things, please reach out and let me know. I can't help you if I don't hear from you, so please be in contact about those things. Alright, we will be continuing with some more proofs in our next unit, our next section. Our next section will be talking about proofs in some parallelograms, and then later on the line we'll have proofs in the coordinate plane, and then we can also prove a few other theorems that we've already talked about.